So lesson 52 is about chemical mixture problems, and these problems usually involve some kind of solution where you have some kind of chemical that has been dissolved in water to create a solution that has a certain percentage of whatever that chemical is. It could be salt, it could be iodine, it could be alcohol, and it's just dissolved in water or mixed with water. And so you are going to be mixing two of these mixtures together to create a third mixture, which is another percent of whatever that chemical or compound is. So we'll look at an example. A pharmacist has one solution that is 10% iodine and another that is 50% iodine. How much of each should he mix together to get 100 milliliters of a mixture that is 20% iodine? So the way that we're going to do these problems is we're going to write two equations in two unknowns, and then we'll be able to solve it by substitution or elimination. So we're going to be pouring in a certain number of milliliters of the 50% solution and a certain number of milliliters of the 10% solution to get 100 milliliters of the 20% solution. Now your book is using the variables p sub n for the amount poured in and d sub n for the amount dumped in, but I, as usual, prefer to just use x and y. X is the number of milliliters of the 50% solution. And y is the number of milliliters of the 10% solution. So for my first equation, I'm going to write an equation just about milliliters of liquid. It doesn't matter how much is in there. I don't care. It's just going to be about milliliters of liquid. Okay, so doesn't matter how much iodine's in there. I just want to know milliliters of liquid. So the first thing I'm pouring in is X milliliters. So X milliliters. And then I'm going to pour in Y milliliters of the other solution. And I want to end up with 100 milliliters because that's what the problem says. So that's my first equation. The second equation is going to be about milliliters of iodine. X is the number of milliliters of the 50% solution. And so since those milliliters, 50% of those milliliters are iodine, I'm going to say 0.5, which is 50%, of X for my first term. That's all iodine. 0.5 of X, 0.5 of those milliliters is iodine. And then the second, I've got Y milliliters of the 10% solution, which means that 0.1 of those milliliters will be iodine. So I've got iodine coming from the first bucket right here. I've got the iodine coming from the second bucket right here. And then I want to end up so that 0.2 of the milliliters I have at the end, which is 100, that's also iodine. So I've got iodine from the first bucket plus the iodine from the second bucket is going to give me the iodine in the final bucket. Okay, so first thing I'm going to do is I'm going to get rid of those decimals because I don't want to work with those. So I'm going to rewrite the first equation just the way it is, x plus y equals 100. And the second equation, I'm going to multiply the whole equation through by 10 so that those decimal points all move over to the right one place. So I'm going to have 5x plus 1y equals 2 times 100. So I just multiplied that equation by 10. All right, I'm going to come back over here and write the equations again. So x plus y equals 100, and 5x plus y is equal to 200. So I've got these two equations, and I'm going to solve this by elimination. I'm just going to multiply the first equation by -1. and add it to the second equation. So multiplying the first equation by -1, and I'm going to have -x minus y equals -100. Second equation is going to be 5x plus y is equal to 200. Add those equations together, the y's go away, and I end up with 4x equals 100. And so x is going to be 25 milliliters. So I'm going to put in 25 milliliters of the 50% solution, because that's what x stands for, and therefore the other 75 will be the 10% solution. So y is going to be 75 milliliters. And that's the answer. All right, we're going to look at another example. You might want to stop the video and try this one on your own, and then you can watch the video and see if you did it right. That would be a great idea. All right, so a chemist has one solution that's 10% salt and 90% water, and another solution that's 2% salt. How many milliliters of each should the chemist use to make 1,400 milliliters of a solution that is 6% salt? Okay, so we have the same kind of situation here. He has one solution that's 10% salt, and they tell you also that it's 90% water. So basically, all these solutions are salt water. So if it's 10% salt, it's 90% water. The one that's 2% salt is 98% water, and the one that is 6% salt is 94% water. And the only reason they're telling you that is because if you want to, in your second equation, you could write it about water instead of about salt, and you'd get the same exact answer. So again, I'm going to say x is equal to the number of milliliters of the 10% salt solution. Y is going to be the number of milliliters of the 2% solution. And now I'm going to write my two equations. The first equation is just going to be about milliliters of liquid. I don't care how much salt is in it. I just want to talk about what's getting dumped out of that bucket. All right, so I'm dumping X milliliters of the 10% solution. I'm dumping Y milliliters of the 2% solution. And the problem says I want to end up with 1,400 milliliters of liquid. All right, now I'm going to write an equation about milliliters of salt. 10% of X milliliters will be salt, because that's a 10% solution. So 0.1 times X, that's going to be salt. Y, those milliliters, 2% of that is going to be salt. So that's 0.02 of the milliliters are salt. We want 6% of the final milliliters to be salt. So 0.06 of the 1,400 milliliters will be salt. So salt from the first bucket plus salt from the second bucket will be the amount of salt in the last bucket. Okay, so we've got, again, two equations, two unknowns. One thing I want to mention specifically in these problems is that when you have something like 50% or 10% or 2%, you never just write it by itself. It's always of something. So in this equation here, I don't have 0.1 plus 0.02 equals 0.06. I would never write that because that's not even true. Okay, percentages will always be multiplied by some other thing, like a number of milliliters. So 0.1 of X, 0.02 of Y, of means multiply, 0.06 of the 1,400 milliliters. So those percentages will always be multiplied by something. All right, so again, I want to use elimination, but the first thing I need to do is write that second equation without all those decimals. So I'm going to rewrite the system here. X plus Y equals 1,400. And then I'm going to multiply that second equation through by 100 to get rid of the decimals. So I've got 0.1x. If I multiply that by 100, it's going to be 10x. And then 0.02 times 100 is just 2, so 2y. And then 0.06 times 100 is just 6, so 6 times 1,400. So now these are my two equations. I'm going to use elimination again because it's easiest to do. So I'm going to multiply the first equation through by -2 so that my y's will cancel. And I will end up with -2x minus 2y is equal to -2800. And then my second equation is still 10x plus 2y equals, and 6 times 1400 is going to be 8400. So when I add this up, the y's will go away, and I'll end up with 8x is going to be 5600, which means if I divide both sides by 8, x is going to be 700 milliliters. So that's 700 milliliters of the 10% solution. And since I want to end up with 1400 milliliters total, y will also be 700 milliliters. So 700 milliliters of the 10% solution and 700 milliliters of the 2% solution. If I pour that into a bucket, I will get 1400 milliliters of a 6% solution.